Now, as much as I prefer Debian over other Linux distros, after a while the packages in the repository become out of date. I mean, at the time of recording, for instance, Debian 12 offers version 4.31 of Podman, which is 2 years out of date. Now, for other software, I've used pip and homebrew, for instance, to get the latest version, but the developers of Podman recommend to only use the repository for installation. Now, Debian 13 is targeting version 5.2 something, but it's still in a state of work in progress, and over time that version will become out of date as well. Into Alpine Linux, which stays up to date. Now, although Alpine Linux has Cloud-Init images, even as of 2024, all but the AWS ones are either in beta or alpha, and try as I might, I couldn't get one to work in Proxmox VE. So, how do you create your own Cloud-Init version of Alpine Linux? Well, if that's something you're interested in finding out, then stick around and watch this video, as that's what we'll be going over. Now, because we're not going to be downloading a ready-made Cloud-Init image, and instead we're actually going to be building our own, the first thing that we need to do is to download a suitable ISO image. So here we are on the Alpine Linux downloads page, and there are actually quite a few different options you've got to pick from here. But what appeals to me is the actual virtual ones here, because they're optimized for virtual systems, and we're going to be building virtual machines, but also these are actually slimmed down, which is ideal for Cloud-Init. So there's different architectures to pick from, so it really depends on what processor you're using. Typically it'll be an Intel or AMD 64-bit processor, so we'll want to click that one, download that file. It also pays to actually check that the file hasn't been tampered with in any way. So we've got an actual SHA-256 checksum here, so I'll click on that, download that file. And then it's a matter of uploading this to actual Proxmox. Now, where you upload that really depends. I mean, you can upload it directly to the local server, to maybe a shared storage. As long as the actual server you're going to be using has got access to it, that's fine. In my case, I'm just going to pick out the local storage for this particular server because we're going to build everything on here. So we go to the ISO images folder here, click on upload. I then need to pick out the file, so I want the ISO file. Get it to upload that. Now, I do want to do an actual check to make sure that the file hasn't been tampered with, so I'm going to change the hash algorithm to SHA-256 because that's what was used. Then what I need to do is to actually get the details of that checksum. So there's our actual file there, so I'm just going to open that up. And I want a copy of that actual checksum, so I'll copy that. Come back to Proxmox here and we'll paste that in here. And then click on upload. So off it goes. So it's not just uploading the file, it's actually checking against the actual checksum that we've downloaded just to make sure that this file hasn't been tampered with. And there you go. Everything's worked as intended, and we've now actually got an ISO file that we can now use to create a virtual machine. Now the next thing to do is to create a virtual machine. So we'll click on Create VM. First thing I need to do is to make sure that this is going to get installed on the correct server. So for me, it's going to be server 1. We also need a unique virtual machine ID, and it does by default pick the next available one. But when it comes to actual templates, I like to give them a much higher number. So I'm actually numbering mine from 9,000 onwards. The reason being is, I mean, okay, we've got a different icon for a template versus a virtual machine. But because these have got such bigger numbers, they go right at the end of the list, so they're much easier to find. Having said that, as of 8.3, we've got a new view, which is tag view. Now with that, you can actually filter on tags. So I created a tag called template, and I've assigned it to the two templates. And now it makes it easier to actually find them that way as well. In any case, I want to go back to creating our virtual machine. Again, I need to pick the correct actual node to install it on. So for me, this virtual machine ID is going to be 9002, and I'm going to call this one Alpine Template. And I'm going to click on Next. I need to point it to the ISO image, so for me it's on the local drive. We're using a Linux operating system, so I don't need to touch that, so I'll click on Next. System settings, typically leave those as is. I mean, you might want to change the BIOS type, for example, especially if you're installing something like Windows, but this is Linux, so I can leave that on a BIOS. We then got the QEMU agent. It's probably the only thing that I would particularly change. Reason being is it allows us to take advantage of some useful features when you've got the agent installed. So enabling this alone doesn't do anything, but if you actually install that QEMU agent into the operating system of your virtual machine, then the hypervisor can talk to the agent, pull back more accurate information about usage, for example, but also it'll be able to do a clean shutdown of the actual virtual machine, which is extremely useful. I'm going to leave the rest as is though, and then click on next. For disks, well, chances are you'll probably just change the storage and the actual size of the disk. That storage location for me is fine. Disk size by default is 32 gig. Now, depending on your actual storage space, you might actually want to reduce that, or you might actually want to set this to a common value for all of your virtual machines going forward. Reason being is that, well, if you've got a common hard drive size already picked out, it just saves you having to make that change on all of your virtual machines every time you create. In this case, just to demonstrate, I'm actually going to set this to 1 gig because Alpine Linux hardly needs any actual resources at all. The rest of the settings we'll leave as is. Click on next. CPU, I don't bother with the sockets. When it comes to the cores, I'll then set that to whatever's going to be common for all virtual machines going forward. Again, as part of this demonstration, I'm just going to leave that as 1. Now the actual CPU type depends. Now, if you've got a cluster, then ideally what you want is all of your servers running identical CPUs. You certainly don't want to be mixing different vendor types within a cluster, so you don't want Intel and AMD processors within the same cluster. You separate them out. You would have an Intel cluster and an AMD cluster, but you don't mix those two vendors together within the cluster. But you could have a situation where the actual family of CPUs that you're using from, say, Intel are just slightly different. That means they've got different instruction sets, and that causes problems. So by default, we've got this emulated type for those sort of circumstances. Now, if that's the case and you do have different CPUs within the cluster, then you'll probably want to leave that as is. Otherwise, it can cause problems for live migrations. But if you've just got a standalone actual server, or you've got a cluster and all of the CPUs are identical, you'd probably be better off picking the option right at the end, which is host, because that would give you better performance. There are other settings you can change here if you like, but I'm just going to leave those as is, and then click on next. For memory, well, this is something you're probably going to set to whatever's going to be common for any new virtual machine going forward that's going to be cloned from this one. The only thing I tend to point out is really this ballooning device, though. I certainly don't see any use for it in this day and age because usually memory isn't that expensive. This would have made more sense when you've got a lab and you're really struggling for physical RAM. The problem you can run into with this enabled is, let's say the virtual machine's got 4 gig of RAM, or at least it thinks it does. In reality, the actual hypervisor is giving it 2 physical RAM. The other 2 gig is actually hard drive storage. You could then run into a performance problem where the actual virtual machine's using 1 gig of physical RAM, suddenly needs 3, and it finds things are just running slow because it's actually using hard drive storage for what should be physical RAM. Eventually the hypervisor will sort it out, but it's just that initial changeover can cause issues. So I'd much prefer if this was disabled by default. It's not, so I just make sure that I remember to disable it each time. And then click on next. Then the network settings, there's various things you can change here. Typically it'll probably be just the bridge if you've got multiple ones. So for me, I've got to make sure I'm using the default one of VMBR0. You'd probably change the VLAN tag if you're using VLANs. And then it just comes down to things like MTU if you're using jumbo frames, for example, because by default it's using 1500 here. In my case, there's nothing else to change here, so I'm just going to click on next. And then you can go through the summary here just to check things out. Then finally just click on finish. And then we just got to wait for the virtual machine to be built. Well, the next thing to do is to install the operating system. So I'm going to pick out my virtual machine here. And then I'm just going to click on the console option up here rather than there, because this one's a bit more flexible, I tend to find. So I'm just going to select that and we'll start the virtual machine from here. Now, by default, it's actually going to try and boot off the hard drive, but there isn't an operating system installed yet. So we're just going to give it a short while to hook in with the actual DVD CD drive, and then it'll actually boot from that ISO image we've provided. Once it actually gets started, it's actually pretty quick to load up the operating system. So we'll just give it a short while and it should then be ready. Now, one thing to point out is that this isn't like some other operating systems where it actually starts the installation process straight away. Instead, you get a live CD. So what we've got to do is actually log in. So we'll log in as root, hit return, and there is no password. So like I say, this is a live CD, so we've actually got to start the installation process. So you do that by using, as it suggests, the command setup-alpine. So setup Alpine. I'm just tabbing that out to finish it. And then we'll just go through a wizard to give it all the information it needs to actually then install the operating system. So for me, the key map is GB, layout is GB. Now, as it suggests, it's probably better to use a fully qualified domain name rather than just a bare bones host name. So for me, that means it's Alpine template. And my domain name is homelab.lam, at least for my lab anyway. We've only got one actual network card on this actual virtual machine anyway. Usually you do. So by default, it's picked that out, either 0, so I'm just going to hit return. I do want to use DHCP and it goes with that by default, so I'll hit return. So since I want to use DHCP, I'll just go with the default option to say no, I don't want to manually configure it now. And then off it goes and actually pulls an IP address from the DHCP server. It now wants the actual password, or at least a new password set for the root account. And now once it's time zone, so for me that's GB. I don't have a proxy, so I can just go with the default option of none. Now, this is where it gets a bit interesting. I do quite like this. You can set the actual mirror from here based on a number. So you can actually list them out if you want. But what I find is a useful option is that F option there. So I'm just going to actually type F because it'll actually go off and test against the actual mirrors. And then it'll pick out the fastest one for me. So I'm just going to hit F. Now, it can take a while because there's quite a few to go through and check against. So it's now actually picked out what it sees as the fastest one. You don't necessarily need to go through that lengthy process if you want to. I mean, there is a command you can actually run later on once the operating system's installed, but it's entirely up to you. Now at a point where it's asking, do you want to set up a user? Now, one thing I'll point out is that's an interesting question because that to me suggests it's a yes/no answer, but it's not. If you do actually want to put in a user, you've actually got to provide the username now. You don't just put in yes. If you put in yes, I can tell you now, you'll actually end up with a user called yes, which, yeah, it's probably not what you intended. So do bear that in mind. But personally, I don't like to leave user accounts on a template, basically because they can change in future. Also, if the account ever got compromised, it would mean every new virtual machine that you build going forward will be stuck with that same user account. So personally, I prefer to avoid that. On the other hand, if you do want to actually create a user, what I'll point out is that the actual Alpine Linux operating system will install doas. So that's a kind of an alternative to sudo. So you can use that for elevated privileges basically instead. So it's entirely up to you. What we're going to be doing is to actually use Cloud-Init to create a user account for us. So in which case I'm going to go with the default option here of no. It then wants to know which SSH server do you want. By default it goes with OpenSSH. So I'm just going to stick with that default there. It now wants to know, do you want to allow root SSH login? Now by default it's not going to allow anybody to remotely log in using a username and password, specifically for the root account. Now, I'm just going to leave that on the default for now, but we are going to change that after. It's not really a good idea. It's not a good best practice to allow remote access for the root account, which makes a lot of sense as to why it's picking by default to actually block it. So like I said, we're just going to leave that as is for now, but I'll change that later, but only temporarily. It then wants to know what the SSH key is for the root account. Now, I must admit, I mean, even if we'd enable that option, I think it's going to be a bit difficult to actually put in the SSH key here because I don't have a paste option. That's the one downside of this console. I mean, I can't really enable like the actual Spice client, for example. So I'm kind of stuck, and that's part of the reason why I'm leaving this ability to log in through the root account disabled for now, although we'll change it later, because there's things like this you just can't do anything about it. I think it would be too difficult to put in a realistic SSH key anyway. So yeah, I'm just going to leave that on the default. Now it wants to know what disk do you want to install Alpine on. Now it hasn't picked one out, but it is telling you what available disks it's got. So for me, we've got SDA, so I'm going to pick that out as the actual disk. It then wants to know, well, how do you actually want to use it? And it gives you a series of options. You can put in a question mark and it'll give you more, but for me, we just want a system disk, so I'm going to put in sys, because that's what it's going to be, a system operating disk, basically. And now we get to a question of, well, basically, do you want to erase this disk and continue? Now, this is basically the final step. If you want to continue and actually install the operating system, you're going to have to say yes. So I'm going to hit yes, and then off it will go and install the actual files. And that was extremely quick. So as it suggests, we want to reboot the actual computer now, because at the moment we're on the live CD. We want to be up and running on the actual virtual machine itself, running off the hard drive. So I'm going to hit, I've typed in reboot there as it suggests. I'm just going to hit return, and I'm going to let it reboot. So it shouldn't take too long, because this time it's going to boot off the hard drive. Now, bear in mind, I'm actually running these hypervisors over here are actual nested hypervisors, so it would be a lot quicker than what you're seeing here. But even still, that was pretty quick. Now, you can basically straight away you can tell we're actually on the real virtual machine now, and we've booted off the drive because the actual name's different. That's the name we actually supplied as part of the actual setup process. And if now I ask to actually log in as root, it does actually ask for a password, whereas the live CD, it doesn't ask for a password at all. So there's our name of Alpine template that I've created, and there we go. I mean, it looks kind of similar, I must admit, because it's still mentioning this option to install Alpine, but Alpine is now installed. Now, again, I can't do any copying and pasting, but even though I should have downloaded the latest version of the operating system, I'm still going to run a check to make sure we've got the latest version of software. So for this, I'm going to have to type everything in. So I'll just clear the screen first, and I'm going to type in APK update. So if you're used to Debian-based operating systems, you're more used to using apt as the package manager. This is using APK instead. So we do APK update to update the repository information that we've got. Then this one's slightly different. I'm going to do APK add -u and then APK-tools, because the idea is, assuming there were actual upgrades to do, you'd actually then want to do an upgrade of the actual packages. Now, what's interesting about Alpine, I'm finding, is the suggestion is to upgrade this APK tools package first as part of the package manager before you upgrade everything else. So that's what we're doing. Is we've got this command of APK add -u APK-tools. It's a bit more complicated, I must admit, than the Debian OS operating system, but yeah, hit return, and again, there's nothing to do here. And then what we would do is an actual upgrade. So APK, and then upgrade, and then whatever's available to be upgraded. So APK upgrade -- available. Hit return, So there's nothing there in my case. Now, because there's some caching possibly going on when it comes to repository packages, what we also suggest you to do is to run the sync command to sync them up. So I'm running sync now. And now what we're going to do is actually power this off because I'm basically done. So we use power off. So rather than say shut down now, to shut down immediately, we use power off. And then it'll power down the actual virtual machine. The reason I'm doing that is because we no longer need the actual CD drive. So it is actually booting up off the hard drive, but I just want to take that out of the equation. So we're going to go over to hardware and we're going to remove the actual CD DV drive. The reason I'm doing that while it's actually turned off is this is the type of change that can't be done on the fly. I would have been able to remove it, but then I would have still had to shut the virtual machine down and power it back up anyway. So it really makes no difference. So I'm just going to select the CD DV drive there, click remove, and that's it. It's gone. And then console back into that again, power it back up again. So it's just taking away the possibility that at some point it might suddenly decide to boot off the CD drive. And really, we just want the actual hard drive version. So as I say, it's extremely light and it's extremely quick to boot up as a result. It's hardly anything running on this. But now I've actually got Alpine Linux installed on our virtual machine. Now at this stage, we've got an operating system installed on the computer, but there is other software that I want to add, there's configuration changes I want to make, but I don't have access to copying and pasting within this console session. So what I want to do next is to actually enable remote access, specifically for the root account. So first thing I'm going to do though is to install Nano. So to do that, we do apk add and then Nano. And then that's installed. So let's clear that session. Then what I'm going to do is to use Nano to edit the actual repositories file. I mean, I could have used Vi, but I must admit, to me, Nano is a much simpler way of doing this. It's a lot easier to make very simple changes to text files with Nano, I find, versus using Vi. I mean, Vi is extremely useful. It's got a lot of versatility, but for me, it just overcomplicates simple things. That's why I'm using Nano instead. But in any case, we need to edit this repositories file. Reason being is by default, we've only got access to the main repository. The line for the community repository is actually commented out. So I'm going to take away that hash and then save the change. Now, for this to take effect, we need to do an update. So apk update, I'll just hit return. And now it'll actually go out and check for packages that are in the community repository as well. Next thing I'm going to do is to add UFW, or uncomplicated firewall, because it makes life a whole lot easier for setting up firewall rules. What I'm going to be doing is allowing remote access for the root account, which isn't good from a security perspective. So what I'm going to do is lock access down to this computer using a firewall. In this case, I'm using UFW just to make life a bit easier. So apk add UFW and hit return. Now, incidentally, I wouldn't have been able to do that without access to the community repository. So let's clear that session out. And then what I want to do is put in a rule. So UFW limit protocol TCP from 192.168.200.10 to any port 22. So in other words, what I'm doing is I'm allowing SSH access, so port 22, protocol TCP, specifically from this IP address. I mean, I could put an actual network address in if I wanted to, but I'm going to lock it down specifically to my management computer. I don't know what the IP address of this computer is going to be if it gets rebooted, because it's using DHCP. Any virtual machine that actually gets cloned from this one could be using DHCP or a static IP address. So I just don't know what IP address is best. So for that reason, I'm using a destination of any. Shouldn't matter too much because there's only one interface on this virtual machine anyway, so that's fine for me. And then I'm using limit instead of allow because that's better for protocols like SSH. It's pretty useful against somebody who's trying to brute force an actual password. So if there's a computer on the network constantly trying to log in using SSH and it keeps failing to get the username and password correct, what this will do is it'll actually lock them out for a period of time. So it's very, very useful against brute force attacks. So I'll just hit return, and it said it's updated that rule. So what we're then going to do is enable UFW. So UFW enable, because by default it isn't started and it's not set up to actually boot from start either. So hit return. Now, what I will say is this is a bit deceptive. If you're used to a Debian operating system, for example, or anything based on that, you would just type that in, run the actual command, and that's it. UFW will always start every time the computer boots up. That's not the case for Alpine Linux here. So even though we're getting that feedback to suggest it's actually enabled on startup, I'm going to run another command, which is rc-update add UFW. Hit return, and now it's said that that service has now been added. So now, going forward, UFW will actually start whenever the actual computer is rebooted. So next thing to check is just to make sure that UFW is actually running. Yeah, it is active, and we're only allowing SSH access from that specific IP address, so that's fine. Now, the next thing I'm going to do is I want to update the actual SSHD config. I want to allow root access, basically. I want to be able to allow somebody to log in as root remotely through SSH. Now, I could actually edit the main config file. The only trouble is every time you upgrade an operating system like this, you can run into situations where that config file gets changed. Maybe something's being deprecated. Maybe there's some new features being added in, which means you've got to keep updating the config file if you make changes to them. What you can do is actually create your own override files, and I think this is probably the better strategy. Now, there's different ways of doing this, but I'm going to use the echo command to create a file. So I'm going to use this to basically create a file that's got permit root login yes. So that's an actual configuration entry within the main config file. Normally it's set to no, so I'm going to change it to yes through override. So to do that, I'm actually going to get it to create a file in the /etc/ssh folder. So sshd_config-d. So we're going to create a file in /etc/sshd_config.d. Now what you want to call this is up to you, but I'm going to call it permit root.conf. That extension .conf is extremely important. The name, not so much. So hit return. It looks like that's actually taken effect. And then I'm just going to double check if that file exists and that it's set the way I want it to be. So, I mean, there's different ways you could have done this. I mean, you could have just used nano if you like. So yeah, so that's now got a line. So because this file exists within that folder, it should get included as part of the main config, and it should override the setting within the actual main config file. So that's extremely useful. Because what it means is every time I upgrade the actual computer to a new major version, for instance, if there's some specific change, I don't have to touch the main config file at all. My override should stay in effect unless that specific setting's been deprecated, for example. But I think that's a much better strategy. Anyway, for all this to take effect, we need to reboot SSHD. So service SSHD restart. And then what I'm going to do is just grab the IP address of this computer, so IPA. So 192.168.102.100. So I want to try and test that. So SSH root, because I want to log in as root, 192.168.102.100. So this already knows about a computer with that. So I'm going to actually remove the fingerprint that we were using before. And we'll try that again. So SSH root 192.168.102.100. So yes, we'll accept that fingerprint. Now it wants to know what the actual password is for root. And there we go. We've now actually got remote access into our Alpine computer, but we're at least locking it down using UFW. Now, if you're going to be cloning virtual machines from an existing one, it makes a lot of sense to actually customize that original virtual machine to your liking. In other words, you want all of the common actual applications installed before you actually start cloning that virtual machine, because it will just save you a whole lot of time. Now, for this demo, I'm just going to install the minimum ones that I think we need. So I'm going to run a command here, which is apk add to add some additional packages in. We want Cloud-Init because we want to take advantage of the Cloud-Init process. util-linux because Proxmox VE actually presents the Cloud-Init config file on an IDE drive, and we need to be able to mount that. It's entirely up to you, but I like to use sudo. I'm just used to Debian computers, and my actual Ansible playbooks actually connect in and use sudo, so I'm including that there. If you go through the documentation for Alpine Linux, it gives you a warning about using Cloud-Init. You can have problems with SSH logins, so it tells you to install OpenSSH-server-PAM. And then while I was going through my testing, I found that I needed to install this extra package. We're using ext partitions by default, and that's the package that you need to avoid this error. It's kind of unusual because we're not actually resizing the hard drive, as you'll see, but without that actual package, it'll cause problems. But even if you did want to actually resize the hard drive, which you probably would, you'd want to include that package. And then we've got QEMU-guest-agent, which is the QEMU guest agent for Proxmox VE to use so that it can interrogate the actual virtual machine, get better accurate resource utilization information, and also to be able to do graceful shutdowns, for instance. So I'll hit return, let it download and install the software. Then what I'm going to do is actually get it to make sure that that guest agent always starts when the computer runs. So rc-update, add, and then QEMU-guest-agent. So it said that's been updated, so I'm just going to clear that. And then I'm actually going to start the guest agent. So that's service QEMU-guest-agent start. So it's now saying that that's actually started. So if we go back to the web browser, so at the moment it's saying that guest agent's not running. Oh, and there you go, it's just updated. So you can tell that guest agent's actually working because you get the IP address. So I'm getting an IPv4 as well as an IPv6 one here. But at least I now know that that agent is working. So Proxmox VE can better talk to that actual virtual machine. Now the next thing I need to do is, like the documentation says, is to enable PAM authentication. So similar to what I did before to allow the root user to be able to log in remotely, I'm using the echo command to basically create this file here. I'm just calling it usepam.conf, and it goes in the /etc/ssh/sshd_config.d folder. So again, that .conf extension is extremely important. It's looking for any file in that folder with a .conf extension to it. So essentially, we're just going to be creating this file, and that's going to be the contents. So I'm overriding basically the main config file. And just to double check, I'll use cat. Yeah, so that's working. So our file exists, but we need to actually restart SSHD for that to take effect. So that's it. So that's basically the bare minimum packages I want to install. I mean, if there's other software you want to install, if there's certain configuration settings you want to apply, by all means do that now. We're at the point where we're just about ready to start setting up Cloud-Init itself, but it makes a lot of sense to install all of your common software, and then you can do some testing afterwards. Now, as useful as cloning is, enabling Cloud-Init does bring some additional benefits. So, for example, you can actually get it to change the host name of every new virtual machine. You can get it to create a new user account, which has got elevated privileges and so on. But before you actually enable Cloud-Init, you do want to take a snapshot of your virtual machine, because this is going to be a one-way process. Now, what I want to do is to actually test that this all works first. If anything goes wrong, I want to roll back to this point in time so that I can fix things. Although, having said that, even if it does go right, I still want to roll back because there's a bit more tidy up work that I want to do before I turn this into, say, a template, for example. So, as you can see, I've already created a snapshot. So what we're going to do is go over to our actual SSH session here. And we're going to run a command which is setup -cloud-init. Hit return, and doesn't seem to do a great deal, but now this Cloud-Init process is ready to go. And that'll take effect when the actual virtual machine boots up, or when any cloned virtual machine actually boots up for the first time. So I'm just going to clear that because I need to add an override into the configuration for Cloud-Init. So basically I'm going to create this new file here called 02-datasource.cfg as an example. And that's going to go in this folder, /etc/cloud/cloud.cfg.d. So basically what we're going to be doing is overriding the main configuration file, similar to what we did with SSHD before. And the contents of that is going to be this. So what I'm doing basically is to change the data source list to just no cloud. There's quite a few other data sources it's got in there, but all we're really interested in is the no cloud option. Because with Proxmox VE, it's going to mount an IDE drive with the actual config file that we need. So this is basically just saying, well, we're only interested in local provisioning, basically. So essentially I'm just using the echo command to create this file in this folder, and it's going to have that as the content. So I'll just hit return, and I'll just check that that's looking the way I want it to. So there you go. So as I say, that's just basically an override file. Saves having to edit the main configuration file. Now that we've done that, we're basically done. So what we're going to do is actually turn off this virtual machine here. So I'm going to use power off to turn this off, and then that's it, it'll shut it down. So we head back over to the GUI. I'm just going to wait for this to turn off because I need to make some configuration changes to it. So let's see, yep, it's actually finished. It takes a bit of a while, I've noticed, for this to update after the actual virtual machine shuts down. But if we go over to hardware, we need to add in some new hardware, specifically this Cloud-Init drive, which is basically an IDE drive. And what we're going to do is, well, where the actual storage is entirely up to you, but I'm just going to put it in the same location as the actual hard drive. So click on add. And now it's created our IDE drive here. And now that we've got that, we can go over to Cloud-Init settings and start configuring this the way we want it to. So for example, I can edit this to tell it to create a new user account, for example, for me. And I'm going to put in a password for that user. And you can override things like the DNS settings that you've got for Proxmox itself, for instance. It's entirely up to you if you want to do that. We can also put in an SSH public key if you want, which is a lot more secure than just a username and password, but I'm going to leave those as is. By default, it'll try to upgrade any packages in the actual operating system as part of the Cloud-Init process. That's actually quite useful. But what's particularly important is this IP config setting. Reason being is, if I edit that, you'll see that IPv4 and IPv6 are both set to static by default, and there's no entries in here at all. The problem is Cloud-Init will fail if you don't at least put something in here or change this over to DHCP. So what I like to do is just switch it over to DHCP. I'm not using IPv6, so I'm just going to leave that as is. But what it'll mean is that when a new virtual machine gets cloned and boots up, it'll start using DHCP to get an IP address, and that'll allow the Cloud-Init process to continue. If I just leave it set to that, the actual Cloud-Init process will actually fail. So like I said, I'm just going to use DHCP, click OK, and then that gets this virtual machine here ready to be used with Cloud-Init. Now the next thing to do is to test that this Cloud-Init process works, specifically when we're cloning a virtual machine from this existing one. So what we're going to do is select our virtual machine. Then what we could do is right click and then click clone, or we'll just go to the more drop down menu and select clone from there. Either way, it brings up the same dialog box. Now there are various settings here that you can change, but you definitely want to leave that snapshot set to current. Otherwise it'll actually clone from the point of time when this virtual machine didn't actually have Cloud-Init installed. So it makes no sense to change that, but everything else is really up to you. Now the actual minimum, you want to give it a name. So I'm going to call this one Alpine Test. Now this is actually going to become the host name of the virtual machine. So it's not just the actual name as it appears in Proxmox here. As part of that Cloud-Init process, it's going to rename the virtual machine to Alpine Test, which is extremely useful. So we're going to click on clone. Then off it goes and clones the virtual machine. It shouldn't take too long because there's hardly anything to this actual virtual machine anyway. I mean, you only give it a hard drive of 1 gig, for instance. So as you can see, that was pretty quick. So we're going to select that. Now, before you power the actual virtual machine on, if there's anything you want to change about this, then do it now. So you could, for instance, change the Cloud-Init settings. So that's useful. I mean, we've got these ones here. These will all be inherited by all new virtual machines going forward, but you can change them on a per VM basis. So for instance, instead of having an IP address through DHCP, you could assign this one a static IP address. Similarly, you can change its hardware settings as well, although you could do that after the actual virtual machine's been created if you want. In with this case, I'm just going to leave things as is, but I'm going to click on console, and then I'm going to click on start. The reason being is I actually want to keep an eye out for any errors or warnings as they go by. So I'm going to click on start. Now this should actually be relatively quick because it's a very lightweight operating system, and basically it's going to boot up the operating system and then it's going to start running the Cloud-Init process. So I want to keep an eye out down this left hand side here in particular for anything that's red instead of green. So there you go, Cloud-Init's now running. It's going through this process here. Eventually it'll stop and we'll be left at a login prompt. And this is the bit of a problem in that you don't get an option to scroll here. So you really want to try and keep an eye out for things here. But the key point is that right here it's saying Cloud-Init final, and then we've got a little green asterisk. So things basically have worked as far as I can see. If there'd been a problem, you'd be seeing warnings and faults, and it would actually say that Cloud-Init had failed, for example. Now there is a line here about this user of type string is deprecated, which to me isn't something I can do anything about anyway. This is more for developers to fix than anything else. But I did see this warning here where it says it couldn't find module named cc_reset_rmc. Now, as far as I can tell, it's not actually causing a problem, but I am interested to know what that actually is. And I did try searching for it, but I just couldn't find anything.
We interrupt this program to bring you an important announcement.
Well, I have since been doing some extra searching to find out what this cc reset RMC module actually is in Cloud-Init. And it seems to be to do with this, to do with basically IBM's PowerVC for the private clouds. So if you go through this, it does make mention of the reset RMC module. And what that's all about is this resource monitoring and control subsystem, which is basically for IBM systems. So if that's not something you're using, which I'm certainly not, then yeah, it's really just a cosmetic issue that you can basically ignore. In any case, it has actually finished. It doesn't seem to be complaining as such. And here we've got a host name, so it's changed the host name over to Alpine Test, and it just wants us to log in. So I'm going to log in using that user account that I created with Cloud-Init. Now, when it creates the account, it grants that user account sudo rights. So we're going to test that with sudo-i. And there we go. We've got our sudo rights, so we're basically showing up as root. Now, one thing I'll point out is that it didn't prompt for a password, and there's a reason for that. So I'm going to actually have a look at a file. So it's in the folder sudoers.d. Yeah, sudoers.d. And it's 90-cloud-init-users. So it creates this file within that folder, which is used to grant sudo rights. So rather than just adding a user to the sudo group, for example, you can be more specific. You can assign them certain commands and so on. But the key thing to point out here is that it's assigning this user account access to all commands, and it's not asking for a password. So that's why when I typed in sudo-i, it didn't prompt for the password. Now that to me is it's not good from a security perspective, so it's something that you'll have to address and fix basically, but I do want to point that out because of the concern. Now, another thing to point out is that the actual groups this user gets added to, so groups in the name of the user. The account's been added to, well, it does create its own primary group of the same name, but it's added the account to ADM and wheel. So these are, it's like high-level groups, which I'm not really comfortable with that, because it means that if you ever take, say, like sudo rights away from this user, they're still a member of these particular groups, which doesn't seem such a good idea to me. In which case, that's something else to look into, basically, because I don't think that's really such a good idea either. Anywho, since these things seem to be working fine, I'm going to check that UFW is actually still working, because it mentioned QEMU, but I want to do double check UFW is still working. So yeah, it is active, and it's locking the actual access down, so that we're only allowing SSH access and only from that specific IP address. So that's good. Then what we're going to do is actually test remote login. So this has been allocated 114. So I'll jump over to my terminal session, and I'll SSH in to 192.168.102.104. So because I haven't put a user in, it's going to use the account that I'm already logged in as on this computer. So just double check that. That's 114. So I'll accept the fingerprint there. That's the password. So now we're logged in that way, and I'll just double check that we can still get access as root as well. Yeah, we can still get access to as the root account as well. Now, from my perspective, everything seems fine. I don't seem to have a problem other than that deprecation and the warning that we got about the module. If you do get any issues, then what you'll want to do is to basically investigate what the actual problems are. Then just delete this actual virtual machine. Go back to the snapshot on the original virtual machine. In other words, roll it back to that point before Cloud-Init was installed, and then apply whatever fixes are needed. Maybe there's a package that you need to install, for example, or as a configuration problem. Once you've done that, you can go back through the whole process of taking a snapshot and enabling Cloud-Init and so on, until eventually you get to this point where everything seems to be working fine. But as I was pointing out, one of the problems I've found is that you don't really get much time to see what's going on if you're just looking at the console. And what you can do is actually look at this file cloud-init.log, which is in /var/log. If we have a look at that file, that actually tells you what's actually going on. So that's another way that you can actually get a lot more detailed information about any problems that it ran into. Because assuming you've just installed some software, I imagine the problem is related to Cloud-Init itself, and that's what you need to fix. So that's the log I would suggest actually checking. So cloud-init.log and the /var/log folder. Anyway, once you get to this point and everything's working fine, what we're going to do is actually turn this virtual machine off. I don't need it anymore because to me the testing's complete. It does seem to be working fine. So I'll just wait for it to actually turn off. And then once it's finished, just jump over that one and back. As I said, there seems to be a bit of a lag between the actual node updating over here to say that it's actually turned off and what I see here. But in any case, now that that's actually turned off, I'm going to actually remove it because I no longer need it. But from what I can see, the actual process of creating a virtual machine and a Cloud-Init process now does look to be working fine. In which case, next thing to do is to tidy things up. So now that we know that Cloud-Init is actually working, the next thing to do is to tidy up and finalize this virtual machine before we put it to use. So what we need to do is to actually roll back to the previous snapshot we took. Now, because this was taken while the computer was running, it's actually going to power up this virtual machine and take us right back to that moment in time. And this is at the point where we were just about to enable the Cloud-Init process. So what I want to do now is to log into this actual computer. So the last octet is 101. So SSH root at 192.168.102.101. And I'll just clear the session there. So now is really the last time to change the password for the root account if you haven't already done that. The reason I bring that up is just that when we did the initial installation, we couldn't really paste into the console. So for me, I think it would have been a bit difficult to put in a really good, complicated password at that moment in time. Easy enough to do is just run PASSWD, and then it'll prompt you for a new password as well as to actually confirm that. Once you've done that, you can then log in through another session just to check that the actual new password is exactly as you think it should be. Now, the next thing I like to do is to edit the resolve.conf file. So that's resolve.conf in the /etc folder. The reason being is that the way this is set up at the moment, if I try to get access to a computer by just its hostname, it'll probably fall over because the DNS server doesn't know what domain it's talking about. So what I'm going to do is add in a new line, which is search, and then the name of the domain name, which for me is homelab.lan. By putting that line in, what the computer will do is to actually append the domain name onto the host name, and then that provides the DNS server with a fully qualified domain name that it should be able to understand. So I'll save that change. Next thing I want to do is to disable remote root login. So I'm just going to remove this override file that we created earlier. Now that was set up because I didn't create an account as part of the initial installation, and the only way I could get access to this remotely was through the root account. So I don't need that going forward, so I should disable it as part of a best practice. And then what we need to do is to restart the actual service for that to take effect. So service sshd restart. So although we're actually logged in remotely to that SSH server, we don't get kicked out as part of it. It does keep existing sessions open. Not all operating systems do that, but this one does, which is good. And then what we should do is just double check that we can't log in as root. So 192.168.102.101. Yep, that's not letting me in. I'm just going to double check, just on the off chance I mistyped. That would be a whole lot better if you just pasted the actual password in, to be fair, but from what you can see, we can't get remote access now, which is to be expected. Now, one concern that I had with that Cloud-Init account was that you could get access to sudo privileges without providing your password, but also the actual user account was a member of some group. So I want to change that by putting in an actual override file. So rather than editing the actual config file itself, which is that, I'm going to add in a new file into this folder. I've called it 03-user.cfg. It's entirely up to you, as long as it's got that CFG extension on it. But this will give me an override for those settings. So what I'm going to do is override the settings, or at least some of the settings for the default user. So I'm just going to give it a blank entry for groups. And I've taken away the no password option here for sudo rights. So what should now happen is when the user gets created, it'll only be a member of its own primary group, and it'll have this entry here for sudoers, in which case I'll have to then supply an actual password if I want to be able to take advantage of sudo rights. So I'll save that file. Now, another thing I want to do is, and when it comes to that reset module that I ran into, to me it's really just more of a cosmetic error, but if you don't want to see that, what you can do is you can actually comment that out. So I'm going to actually do that by using the sed command, -i is to override. So there's a line in the actual config, which is this reset_rmc. That's the module it was looking for. And I'm just going to put a hash in front of it. So we're basically editing the config file and replacing any entry like that with that. And then now what should happen is it won't actually run that module. Again, it's more of a cosmetic thing, so you don't necessarily have to do that. It's entirely up to you. So the next thing to do is we're now at the point where we actually want to now test this out again. So what I'm going to do is I'm going to go back to here. I'm going to take another snapshot. I'm just going to call this one last snapshot, for instance, and take a snapshot. Because what I want to do now is to actually enable the actual Cloud-Init process. So it doesn't take long because the actual hard drives are very small for this. Taking a snapshot. So now what I can do is I can go back to my actual session here, and then we can run Cloud-Init again. So setup -cloud-init. And then what I'm going to do is to override the data source again, because the only one we're interested in is the no cloud data source. So we're just putting in this entry here into this config file here, so that acts as an override. So it's exactly the same as what we did before. And then what we'll do is power off the actual virtual machine. So I'll just wait for this to power off. And then the next thing to do is, as before, we need to add in the Cloud-Init drive. So I'll go over to Hardware, click on Add. We'll add in a Cloud-Init drive and just set the actual storage location. And then I just need to put some details into the actual Cloud-Init settings here. So typically we're going to put in a user account and a password. Ideally, it would be better if you put in an actual public key or SSH, but you always need to remember these settings here, because otherwise Cloud-Init will fall over. So I'm going to change that over to DHCP and click OK. And then now really we're ready to do our hopefully final test. Well, hopefully this would be our final test, but we do need to double check that the virtual machine that we've got here can be cloned and we won't end up running into issues. in which case I'm going to select that virtual machine, and then from the more drop-down menu, select clone. At the very least, I need to provide a name, so I'm just going to call this test and click on clone. And then we've just got to wait for that virtual machine to get created. Now, you can, if you want, change the actual Cloud-Init settings on a per VM basis. I mean, these don't take effect until the actual computer boots up for the first time and Cloud-Init kicks in, but I'll leave those as is. Similarly, you can change hardware settings as well, but instead I'm just going to click on console, then click start now to power this up, because I want to watch things as they go by. So what we should expect is the operating system will boot up and then Cloud-Init will kick in. And the thing I quite like about this is you get these little green asterisks down the left hand side. Well, hopefully green. I mean, if you get any red ones, then yeah, you've got problems. So Cloud-Init has now kicked in. So we just need to wait for that to finish. So there you go, Cloud-Init final. So it hasn't reported any errors as such. I mean, we do still have this deprecation warning, which, like I've said before, to me seems more to be a problem for developers than us, so that's fine. There's no sign of the issue we had around this reset module, which is to be expected because I did comment it out. The name of this actual computer is test, which matches what we asked for when we cloned it. So I'm going to log in with a non-root account just to make sure that that works. And then we should have sudo right, so sudo-i. Now notice this time we do get prompted for a password, which is exactly what I want. Before, or at least by default with the default config settings for Cloud-Init, I was able to basically get access to these sudo rights without having to supply a password. So this to me is a lot more secure. So I'll provide my password and sure if that's working. Next thing I want to double check is what groups does that user belong to? Well, this time only to the actual primary group. Before, I believe by default the account would have been added to ADM and Wheel, so that's no longer the case. That's good to see. I'm going to check UFW. So again, you can get SSH access to this computer, but only from that IP address, and actions set to limited. So if anybody tried to do a brute force attack, even from that specific IP address, it would at least do something to try and minimize the actual risks there. So that's good. So now that that seems to be fine, I just do want to double check SSH. So I need its IP address, so 117. So I don't need to provide a username because the user I'm logged in as is the same as the non-root account user. 192.168.102.117. I'll accept that fingerprint. Supply the password. So that worked fine. But I do want to make sure that we can't log in as root. And that's not going to help, so root. So just to be extra safe, I'm going to copy and paste in the actual password for root. Yeah, it's not letting me in. So even though I am supplying the correct password, it's actually refusing to let me in because we're blocking root from actually logging into this computer remotely through SSH. So that's another good thing to see. So really that's it. Everything seems to be fine. In which case what we're going to do is turn this off now because we've done our testing. So we'll just wait for this to power off. And then what I'll do is just delete the actual virtual machine because really I no longer need it. So I'll just apply the proper ID for that and remove. So now what we've got is a virtual machine that we can actually clone. Now where you go from here is entirely up to you. I mean, we've just got essentially a normal virtual machine. You can turn it on. The problem with that is if you were to power this virtual machine up, Cloud-Init would kick in, and that could cause you problems if you tried to then clone it afterwards. On the plus side, we do have a snapshot here, so we can always roll back to that snapshot, add software, remove software, make other config changes and so on, and then rebuild it and get it ready for Cloud-Init again. So I'd say that's one of the benefits of having so like a virtual machine. The downside is this could get broken as a result. You can go in and you can make changes to it. So normally, and for a long time, you've created what's known as a golden image. So that's a one-off setup. It's got the operating system, it's got all the necessary software, and that's it. It never changes after that. What we don't have quite here is that, because you can make changes. So that's just something to bear in mind. But it's just that benefit. You can go, as I say, you can go back to a previous point in time and make changes to this one. So you can always just call it there and say, well, that's enough for me. All I'm just going to do is clone this virtual machine. Having said that, there are other options. So for me, for instance, if I was to create a new image, say like an upgraded version of Alpine would have come out. So this was a major version. Well, to be fair, I would delete this particular virtual machine anyway and start from scratch, because I'd rather have a fresh installation of a major operating system than one that had been upgraded from a previous version, because there's going to be certain software that gets carried over as part of that upgrade usually. So personally, I prefer to just have a template that's got the minimum amount of software on it, and then I'll actually just hand it over to Ansible. So that's what I've done here. There's only enough software to get it going, and then Ansible will take care of the rest, installing the necessary software depending on what that virtual machine is going to be, making sure all the various security settings and so on is all in up to date, cronny is configured properly, the firewalls configured properly, and so on. So for me, I always just create a bare minimum template, and it's just a one-off, and that's it. But like I said, it's entirely up to you. But there are actually other options. So for example, you could actually turn this into a template, for instance, and typically that's what most hypervisor admins would do. So we'll cover that in the next chapter if you're interested in doing that. On the other hand, what I do is to create Cloud-Init images. I no longer keep templates on the actual hypervisors. I do in this lab, but normally I just don't bother with actually templates stored on the actual hypervisors themselves. Now I'm just using Cloud-Init images, in which case that's all I'd be interested in. Now, what you can do is, if you're just interested in that particular aspect of it, then feel free to skip ahead over the next chapter, which will be about templates, and just jump straight into Cloud-Init images. Now, usually when you're cloning virtual machines, you actually use what's known as a template. To me, it's more of a read-only virtual machine because you can't make any further changes to it, or at least not in software. And that's because, well, you can't even power the thing on. So I've got a virtual machine that might be called a template as such, but as you can see here, I've got a start button. If I go to any of these other two actual templates here, and you'll notice the difference based on the little icon to the left, you can't actually power these ones on. There isn't even a console option here. And that's deliberate because, like I say, it's sort of a read-only virtual machine. The idea is you don't want to make any further changes to it. It works, and the last thing you want to do is to actually break it. So what we've got here is a virtual machine. Now, in order to actually turn this into a template, there is one slight catch, and that is you have to delete any existing snapshots first. I mean, if I go to More and select Convert to Template, it says, oh yes, do you want to convert this to a template? Yes, I do. Oh, you can't. It's got snapshots. So it gives you a last minute warning essentially to say you can't do that. So really this is a one-way process essentially, in that once I delete this snapshot, specifically because of this virtual machine running Cloud-Init, I can't go back to that point in time of the snapshot before Cloud-Init was installed. But for me, the virtual machine works. I don't need to make any further changes to it anyway, so that would be fine. So I'm going to click on Remove, take away the snapshot, and that's it. So with the snapshot removed, we can then go back to our More drop-down menu and select Convert to Template. Alternatively, you could right-click on here and select Convert to Template. Either way, we're going to go through this process, and it does ask you to confirm that you want to actually convert this into a template. So I'll click on Yes. And now we're getting this warning because you can't do anything further with this. Like I said, that's deliberate. You want to basically a read-only virtual machine, but we've now got a template. So bear in mind, this is a one-way process, at least as far as the GUI is concerned. Again, you can't start it up. Doesn't seem to be an option to convert it back. If memory serves in ESXi, I think you can actually revert a template back to a normal virtual machine, but Proxmox here doesn't seem to be letting us do that. However, if I open up a shell session, there is a command we can run which is qmset, then 9002 -- template, and then 0. So it's basically like a Boolean flag, really. So basically we're telling it to undo this, essentially, because that's what it's done. It's changed the flag for this actual, what was a virtual machine, and now Proxmox treats it as a template. But I'll hit return here. So it's finished. So we've got to give it a short while, but eventually this should actually revert it back. So there you go. So now it's an actual virtual machine again. So that's actually quite useful. The only downside is, well, we don't have our snapshot anyway, so just something to bear in mind. Anywho, now that we've got a temp, well, I need to convert this back to a template actually, so I'll just do that again. But what it then means is you've got your golden image, basically. This is a read-only virtual machine, which the only intention really now is to clone it. I mean, we've still got things like Cloud-Init settings and hardware settings on this. So there's some of these you can actually change, even though it's an actual template. So there is still that possibility, but we can't power it back up, make any changes to it. Yes, I suppose you could say we could revert it back to a virtual machine and do that. The only trouble is this is a kind of a special virtual machine, and that it's now going to be running Cloud-Init every time it powers on. So yeah, we couldn't do that anyway. But hopefully that might be something useful for any other virtual machines you've got. So the process of creating another virtual machine from this one is exactly the same. We just select that, click more, tell it to clone it. I'm just going to call this one, as before, test, and we'll tell it to clone it. So now we're just cloning from a template as opposed to a virtual machine, and they're all basically exactly the same apart from that one setting, basically, by the looks of it. We're going to select that. We could change these settings here, change the hardware settings if we wanted to, but we're just going to power this up. I want to make sure I'm in the console. I mean, it should work fine because we've already tested it. It's essentially exactly the same virtual machine as before that we've cloned from. So I'll just wait for this to boot up. So again, go through the operating system load, then we'll go through Cloud-Init. Now, I'm not going to bother testing it because we've already done that, but there is something I'm going to show you which I think would be useful. So we'll just wait for this to finish and then we'll log in. So its IP address is 119. Set that fingerprint. Now, what I want to do is to actually disable this Cloud-Init process, because there's certain parts of it will still run every time that virtual machine powers up, and it can throw errors at you, for instance. So what I like to do is to actually just disable Cloud-Init. Once I've actually got the virtual machine itself built, I want it disabled. I no longer need to use it. And I also want to tidy up this virtual machine. So to do that, what we're going to do is run this command. Basically, I just need to create this specific file. It doesn't need to actually contain anything, but as long as that file exists within the /etc/cloud folder, when Cloud-Init boots up and sees that file, it won't run. So that's why I'm just using the touch command there to do that. except I don't have the rights, so I'll do that with sudo rights. There we go. So now that I've done that, I'm just going to power it off. Again, I need to put in my sudo right option. So I'll just wait for this to power off. And then what I like to do is then tidy it up basically by removing all of these settings, because these are things that somebody might see over your shoulder, for example. So ideally, you don't want anybody knowing a user account that exists on the computer. I mean, okay, the password's blurred out, but even something like a user account gives somebody a bit of a head start. So I'm going to reset these back. I'm just going to remove them all together so they're not actually seen. I'll take that out. I'll just set it back to static. It doesn't really matter. That probably makes more sense if you had a static IP address, I must admit, versus DHCP. But again, it's just, to me, it's just useful that nothing here gives anybody an advantage if they would just happen to notice over your shoulder with these settings. So now that I've done that, what I'm going to do is actually go to hardware, and I'm going to remove the Cloud-Init drive. So the reason I've done them in that order is that once you remove the Cloud-Init drive, you can't get access back to here, and these things would be kind of stuck on there permanently, essentially. So that's why I do it in that specific order, but they're now gone now. Now you don't want to do that to the actual template. This is something you do to the actual virtual machine, by the way, just to point out. But anyway, we'll go back to the console and we'll power it back up. Now this time we should only get it actually booting up with the operating system. It's already configured to get its IP address through DHCP anyway. So we're no longer reliant on that Cloud-Init, hence why I took it away. So there, as it says, as far as it's concerned, Cloud-Init's disabled. So we've still got a working machine, except now, and going further forward, this virtual machine won't be doing anything involving Cloud-Init, so it's not going to change. So I do much prefer to do that. So at least now, though, we've got a virtual machine that's been cloned from our template, and it's all ready to use. Now, as useful as templates are, I prefer to use Cloud-Init images, and I just hand those over to Ansible to automate everything. Now, I could get Ansible to clone a template or a virtual machine. The only trouble is it's a bit more complicated, and it also takes a bit longer, especially if you're going to be cloning quite a lot of virtual machines. So when it comes to creating these Cloud-Init images, the actual process is going to be the same whether it's a virtual machine or a template, because all we're interested in is the actual hard drive. Now, if it's a virtual machine, you want to make sure that it's powered off and that you've removed any actual snapshots from that virtual machine. Now, I've already taken care of that with this template that I've got here as part of the previous process, because I've converted it over from a virtual machine to a template. So I already had to remove the actual snapshot, and you can't actually power up a template anyway. So the next thing we need to do is to actually find its hard drive. So I'll select that virtual machine and go to hardware. And if you look at the hard disk here, you can see it starts with the actual storage location and then the name of the file. So to find out where that is, we'll go over to data center, and then in storage here, we'll get a path/target. So that's where we're going to be looking for the file. Now, if this had been on my NAS, which is an NFS share that I've got here, I'd be looking in /mount/pve/vms. If it had been on the local drive, I'd be looking in /var/lib/bz. The trouble is, it's on a local disk, which is using ZFS. There's no path or target because it actually breaks the file up into chunks, basically, so I can't really get direct access to the file. So what I'm going to have to do is actually move the hard drive. So we're going to go over to that actual virtual machine. Go to hardware, select the drive, go to disk action, select move storage, and I'm going to put this on the NAS. Now, when it comes to the format, I would suggest just go with whatever the default is. Reason being is it can cause problems later on. So let's say I had a virtual machine and I actually wanted to put that on the NAS. would be tempting to change the format to raw because you'd get better performance, supposedly. The only trouble is, in a raw format across an NFS share, you can't do snapshots. So that would be a big problem for an actual virtual machine. That's one of the key benefits of a hypervisor, is to take snapshots. So, like I said, I would really suggest just sticking with the default, which in this case it's already picked QCOW2. We then got an option to delete source, which I am going to do because basically it's just going to copy the actual drive across to the NAS. But I don't see any benefit of leaving the original file on the local disk. It's just going to waste space. So enable that and then click Move Disk. Now, it doesn't take too long to actually do this because it's a very small hard drive, but what we'll notice shortly, it's going to throw an error message. It's trying to run a command basically relating to the actual file attributes down here, and it can't do that. Now, this only seems to apply to templates. If I revert it back to a virtual machine and do it, it works fine. So it only brings this message up if it's a template, I've noticed. Ultimately, it's saying it's been able to do it, so I'm not too concerned about that because it'll still work anyway. So we'll close that dialog box there. Now our file's moved. So what we want now is a copy of that file. So you could SSH into the server. I'm just going to open up a shell session. So I'll select the server, go to shell, because I've still got copying and pasting here. I want to just double check the actual file. So we'll do ls-l, then the name of the storage. So for me, it's /mount/pde/vms. In the storage, you'll have a folder called images. And within there, you've got subfolders with the ID of what is either a template or a virtual machine. So this one is 9002. So we'll look in that folder, and there's the file. Now, the naming convention depends on whether it's a template or a virtual machine, for instance. So if we go and have a look at 100, which is that virtual machine there, this one actually starts with a VM. So a template seems to start as base, a virtual machine starts as VM. What I want is a copy of that file. Normally I would upload it to the Ansible server, but what we're going to do is a manual process of creating a virtual machine and then adding in the hard drive. If you're actually interested in how to do this using Ansible, I do actually have another video that shows you how to do that. But what we're going to do here is just basically copy the file, and I'm going to store it in this local folder. And I'm going to give it this name of my_no-cloud-alpine-latest. All that really matters is that extension matches. Now, I could put in version numbering here. The only thing is I'm going to be using this with Ansible, and it's just going to cause problems probably down the line if I actually put the version number in. Every time I create a new version of this image, if it's got a different version number, I'll have to go off and update Ansible as well. So that's why I'm sticking with that. So I'm just going to check that that file is there. So there we go. Now, what I need to do now is to actually create a virtual machine. You could do it in the command line, but I'm just going to do it from the GUI here. So we'll click on Create VM. Just do something simple here. So I'm just going to call this test. The operating system, well, we don't actually need a CD drive. We've actually got a ready-made hard drive here. Default operating system is Linux, and that's what we're using, so that's fine. System settings, well, I'm just going to select QEMU agent here. Disks, well, I don't actually need a disk because we've already got one, or at least we will do shortly. CPUs, I'll leave those as is. I'm just going to change this over to host to get better performance. For this demo, I don't really need many CPUs anyway. Memory, I'm just going to leave that as is, but I'm going to disable ballooning. For the network, I just need to select the proper network here. So I'm going to select that bridge, which is the default one. I'm not using VLAN, so that's fine. Click Next, and then click Finish. And then that creates an actual virtual machine. So that's creating a virtual machine, which is 104. So that's ready. So now what I need to do is to actually import this hard drive that we've got. So we're not actually moving it. This is not like a one-off thing where I'm taking that file and it now belongs to the actual virtual machine. We're basically taking a copy of this hard drive and creating a new one for the actual virtual machine. So to do that, use this command qm import disk, then the ID of the virtual machine, then the actual name of the actual hard drive in this case, or image, followed by the storage. And then we're using qcow2, so I've got to put in that parameter of format qcow2. And then we'll just wait for it to import that to the virtual machine. So that's now done. So we'll go over to our virtual machine. So now right at the bottom, we've got a hard drive. So we'll select that, select edit, and then just click on add. So that's now got an actual attached hard drive that we can use. While I'm here, because we're using Cloud-Init, I'm going to add a Cloud-Init drive. I'm just going to put that in the same location as the hard drive and click add. And then we need to edit the Cloud-Init settings. So I'm just going to give that a name that we can use to log in with. I'll put in a password. I mean, it would be better to put in a public key, but for the sake of this demo, I'm just going to use the name and password. Do need to remember to set these IP settings depending on what you're doing. In this case, I'm just going to stick with DHCP. Then I'm going to go over to options because I need to tell it about this actual hard drive. I need to actually boot from the drive. So for the boot order here, we'll select edit. I'm going to drag the hard drive all the way up to the top and click that. So now that's basically the primary choice for booting from. Then we'll click OK. So it's got an extra hard drive for Cloud-Init, but really what it's interested in is booting off this drive here. So now that that's done and we've set the boot order, we should be able to boot this up. So click on the console here so that we can watch the process as it goes by. Click on Start Now. And then what it should do is it will boot up the operating system, but because this is all prepared to use Cloud-Init, we should then see Cloud-Init kick in. So as far as I can tell, it should work fine because this is all working all tickety-boo when we created this template here. So we shouldn't have any issues other than basically just a deprecation warning, and that's about it. So off it goes, it's got its IP address. I'm just waiting for that to finish off again. Yep, there's our deprecation warning, which is fine for me. And then we've got a nice green light there against Cloud-Init Final, which is to be expected. I mean, basically in this state, it would have either just completely fallen apart or worked. That would be the expectation, because we already know the hard drive works anyway. So because we named it test, it's been given the name of test. So just log in and check. Okay, so its IP address is 102.101. So just accept the fingerprint and supply the password. So now we're logged in. So there's no point actually testing this any further because I've just demonstrated a different way you can take advantage of Cloud-Init. Basically, we've now got a Cloud-Init image drive essentially, which is basically just a ready-made hard drive that you can attach to any virtual machine that you create. So like I did in the previous chapter, what I'm going to do is to actually disable Cloud-Init on this actual virtual machine, assuming I was actually going to use it going forward. To do that, you run touch /etc/cloud/cloud-init.disabled. So basically we're just creating this file in the /etc/cloud folder. As long as Cloud-Init sees that file, it won't run, and that's what we want. Except I need to do that with sudo rights, don't I? So that's created that file. So now when we actually try to boot this up, Cloud-Init won't work anymore. And that's intended because I don't want it to make any further changes to this virtual machine. It's all ready to go, it's ready to use. So I don't want it getting altered, because there's certain stages within Cloud-Init that do run again. Also, if you actually disable the Cloud-Init drive, which I'm going to do next, you can then start to see error messages pop up when it actually boots up. So I prefer to just disable this entirely. So now that that's done, I'm going to turn this off. We'll go back to our virtual machine. We'll just wait for this to turn off. And then what I'm going to do is to actually remove the Cloud-Init settings, because I like to do that because the virtual machine's now ready. It doesn't need Cloud-Init anymore. But I've got information in here which somebody might see over the shoulder, should we say. So we're talking about things like a username, potentially a static IP address if that was here. So I'm just going to remove this information, essentially reset things back to their defaults, because they're no longer relevant anyway. So I'll just set that back to static. I mean, the actual operating system already has an IP address. It's already set up to use DHCP, so it doesn't need this information. So now that I've done that, I'm also going to take away the Cloud-Init drive. We'll go back to the console, power that back on again. Then we'll just double check it works. It should do, except this time the only difference is we should see that it just basically skips the Cloud-Init process. So again, it'll basically boot off the operating system, but then when it gets to Cloud-Init, it'll just say, well, that file already exists. I'm not going to do anything. There you go, saying that it's disabled. So obviously you can see that the boot process is even quicker still because it just didn't go through using Cloud-Init. So I'll just log in, assuming I can actually type the password. There you go. So we've now got a ready-made virtual machine, but what I particularly like about this is I've now got an image, if you will, which I can basically hand over to Ansible, and then it can then just go through this repeated process every time I want to create a new virtual machine. And that to me is a much easier way for creating virtual machines. I must admit, the process for creating an Alpine Cloud-Init image was rather lengthy, and I found that it was prone to errors. It actually took me quite a while to fix various problems along the way, but in the end, I now have an image that's ready. As per Proxmox's documentation though, creating your own image is the safer method. In any case, what I have now is a more slimline OS that is quicker to boot and has a smaller attack surface. Best of all, this allows me to take advantage of newer versions of packages such as Podman. But what OS do you use for your container platform? Let me know in the comments below. Now, if you find this video to be useful, then do consider subscribing to the channel, as that would really mean a lot to me. But it's also a good indicator to let me know how videos like this are helpful to people such as yourself that are watching. In which case, thank you. On the other hand, if you're not ready for that level of commitment, then I'd really appreciate it if you could press the like button, because that way that'll help to get the video out to other people that might find it useful as well.